Ladies and gentlemen, today I'm going to present the conference paper entitled Diagnosing Coronavirus using various deep learning models, a comparative study. The authors' name are Omran Shamma, Muhammad Abdurrahim Fadl, Layth Zubaydi, Layth Farhan, and Muthanna Al-Amidi. These authors are from different universities and countries like Iraq, Australia, United Kingdom, and United States of America. As you know that COVID-19 is first appearing at Wuhan city in China at the end of 2019. It rapidly spread out to other countries around the world. Thus, it's become a pandemic rather than a pandemic. Early detection can save people's life effectively. Regarding to diagnosing respiratory disease, the X-ray, CT scan are most commonly used. X-ray is more reasonable and it's available in all clinics and hospitals, while the CT scan is more desirable because it offers a 3D view. It's not available in most clinics and as well as hospitals. Both X-ray and CT scan are currently used by doctors to detect COVID-19. In contrast, artificial intelligence as machine learning, neural network, and currently deep learning models are applied to diagnosing different diseases like sickle cell anemia, breast cancer, diabetic foot ulcer, and so on. This encourages researchers to develop smart models for early detection of COVID-19. The most well-known models include AliNet 5, AlexNet, VGG, GoogleNet, and the RiseNet. These models have different architecture, but all are based on the architecture of convolutional neural network. The convolutional neural network has mainly three different layers which are in sequences: convolutional layer, polling layer, and then the fully connected layer. As seen in the figure, this is the input layer, convolutional layer, polling layer, fully connected, then the output layer. The convolutional layer for feature extraction, polling layer for generating features map, and fully connected for classification. The number of layers are different from one model to another, and thus different architecture. This comparative study used four famous deep learning models: AlexNet, GoogleNet, VGG, and RiseNet. Two comparative parameters are used: diagnostic accuracy and processing time. Also, for real-time purposes, the GPU platform as a parallel process architecture is applied, as well as the general CPU platform. However, for accurate comparison, the input dataset for all models can be the same. Also, the models deep learning and need a big dataset, so 3000 CT scans are collected from online resources like the casual website for of these images. 1800 images are infected with COVID-19 and the others are healthy. The next step to pre-processing the dataset: first, only the area of interest is separated, scaled to the input CNN form, and then normalized into 0 and scale values. The model processing consists of three stages: training, validating, and testing. Therefore, the datasets are partitioned into three sub datasets: 18% for training, 10% for the validating, and the 10% for testing. As you can see from the table, the models are order ascending with the, respect to the diagnostic accuracy, while the descending order for the processing time. The processing result show that the RiseNet has the highest diagnostic accuracy, but the slowest one. With the GPU platform, the processing time ID decreased too much, as all models become suitable for use in real-time applications. The accuracy did not change. These figures show sample of the result for the VGG and GoogleNet models, and these for AlexNet and RiseNet models. You can see the big accuracy of the RiseNet, as can see. This is non COVID-19. This is infected by COVID-19. This table is the general summary of performance for both platform CPU and the GPU. You can see that the different models, VGG, GoogleNet, AlexNet, RiseNet, has the diagnostic accuracy is the same in two platforms, CPU and GPU is the same accuracy, but different in time of the training and testing time. This is a big difference between the CPU and the GPU. The CPU is a serial processing and GPU is a parallel processing, as we said earlier. Here in conclusions, four famous models, AlexNet, GoogleNet, VGG, the RiseNet, and are used in this study. RiseNet has the highest accuracy for more than 94%, but it's the slowest one. At the end, thank you for your listening.